Hi everybody, these are our movie for finding the mixed water temperatures when we're mixing two uneven amounts of water. And these are the steps, and I'll put these up now as we work through this. But what we really want to do, if we have two things of water, and we'll just use these two, and we mix them together, what we want to do is try and find out what their mixed temperature will be using calories. And so when we do this, our first step is simply to know the range of possible answers. And what that means is if you have something at 15 degrees and something at 38 degrees, the mixed temperature has got to be somewhere in between those two amounts. You won't mix these and have a temperature of 5 degrees or 90 degrees. It's got to be somewhere between 15 and 38. So I'm going to write that in up here, that's where our answer window is. It's between 15 and 38 because that's going to help us check our work. So the first one is to find the calories in each sample, and we do that by multiplying the milliliters times the temperature. And when we do that for this one, 15 times 20 equals 300 calories. And this one, 38 times 30 equals 1,140 calories. We've now completed step 2. We found the calories in each sample. Then it says add the calories of both samples together to find the total calories of both samples. So now we take our calories and we just add them together, and those two together come out to 1,440 calories. And so now we've got the total combined calories. The next step is add the milliliters of both together, so we find the total milliliters. So we have 20 milliliters and 30 milliliters. We have a total of 50 milliliters. Now we're actually ready to solve and find our mixed temperature. It says divide the total calories by the total milliliters. This gives you the mixed temperature. Well, if I divide 1,440 by 50, I get an answer of 28.8 degrees Celsius as my mixed number. So I'll just say that is the mixed amount right there. And finally, the last step, once I found it to make sure I didn't make any mistakes, check it against your, check to see if your answer falls in the range you found possible in step 1. Well, in step 1, we said our temperature had to be somewhere between 15 and 38 degrees, and it is. And if you make a mistake on this and you multiply something when you add it or you divide backwards, you will not get an answer that's even close to the range it's supposed to be in, and it will let you know if you've made an error. So, once again, every time you do this, you can draw these out in pictures like I have, which I really recommend because there's a lot of numbers here to get mixed up in with an awful lot of different tags on those numbers. And follow those steps, and every time you'll get the correct mixed temperature. And you can take a screenshot of that if you need it. Now, the other one I want to show you is to show that we can do the same thing to solve these amplify problems. And this is actually question 1, or one of the questions on the practice test. And so it gives us these little circles, and the circles stand for the mass, and the numbers in it stand for the temperature. And this says it's a pan, but we can draw this as water. And here's how we can do that. We simply will make, for this one right here at 20 degrees, we'll say it's 1, 2, 3, 4, 5, 6, 7, 8, 9 milliliters, since each of these stand for a cubic centimeter milliliters. So that gives us 9 milliliters of fluid. And then we have 20 degrees. So we can draw it up as water. This one right here that we're mixing it with, it's got 1, 2, 3, 4 milliliters, and it's at 100 degrees. Now that we've got it looking like water, we can solve it the exact same way as we did this one. And this, first of all, we find our total calories, or find our range. So we know that our answer's got to be between 20 and 100. Now we find our total calories in each one. 20 times 9 will be 180 calories. 4 times 100 will be 400 total calories. Next step, we find our combined calories, and that will be 580 calories. And then we find our total milliliters. That is going to be 13 milliliters. And then I grab a calculator because I can't do this in my head. I grab a calculator and we divide the total calories by the total milliliters. That's going to be 5,000 or 580 rather, divided by 13, and that gives me a temperature of 44.6. So my mixed temp equals 44.6 degrees Celsius. And finally, I check that to make sure it falls in my acceptable range, and you can see it does. The point on this, though, is even though they put a picture in here and they call them pans, if we just think of each of these circles as a milliliter, and then just think of those numbers inside them as the temperature, then we can draw it up as water, and we can solve it the exact same way that we did here. And that's it for the movie on how to find mixed temperatures, both with water and amplify questions. I hope you found it helpful. Thanks for watching.